All right, so 2.13, an extenuation from yesterday. Example 5, here we go.
Let f of x equals natural log x plus 15 minus natural log x, and let g of x equals natural log x plus 3. Find all values of x where the graphs of f and g intersect. Oh my god.
All right, so when do things intersect? When they cross, right? And so how do we figure out where they cross? We set them equal. All right, and so that's what we're going to do. So we're going to set f of x equal to g of x. So now we have natural log of the quantity x plus 15 minus natural log of x is equal to natural log of x plus 3. And so can I just strip away the natural logs right away? No. And so what do I have to do to this left side? This subtraction actually means what? Division. And so now we have natural log of the quantity x plus 15 over x is equal to natural log of x plus 3. And so now can we strip away our natural logs?
Yes.
Yeah, we use a one-to-one property. And so we strip it away, and then we're going to multiply by what? X. So let's just go ahead and multiply by x. So now I have x plus 15 is equal to what? X squared plus 3x. All right, and so I'm going to set them on one side of the equal sign, and so I'm personally going to move them to the right to keep my x squared positive. So now I have 0 is equal to x squared, and then what? How many x's? 2 x's, and then minus 15. And so now I'm left with the quadratic, and what do we want to do to quadratics? We're going to F them up, so we're going to factor it. And so now it factors to x plus 5 and x minus 3. And so I end up getting x equals -5 and x equals 3. Now, I need to check to see if any extraneous solutions are happening. So when I substitute in -5, does it break here? No. Does it break here, though? Yes. And so x equals -5 is extraneous. All right. And so now I check for 3. Can I substitute 3 back in and be all good? Yes. And so my solution is x equals 3. All right, let's do it again. And so now I have h of x equals that, and k of x is equal to that. What are the coordinates of the points of intersection of h and k? Again, what do I do when I try to find intersections? Set them equal. And so let's set them equal. So now I have log base 3 of 2x minus 3 plus log base 3 of x plus 4 is equal to log base 3 of 8x plus 2. So what do I have to do first to the left side before I'm allowed to strip them away? I have to combine them. And so what are we going to use? That 4-letter F word called FOIL. All right. And so now we have log base 3 of, what is my first? 2x squared. And my outers and my inners, so my outers are what?
4x.
2x times 4 is 8x, and then my inners is -3x. So how many x's do we have? 5x. And then my lasts are minus 12 is equal to this log base 3 of 8x plus 2. And so now what can we do? We can strip it. We can get rid of our logs. And so I'm going to put them on one side of the equation. And so I'm personally going to move them over to the left. So now I'm left with 2x squared, and then how many x's? Minus 3x, and then minus 14 is equal to 0. And again, I have a quadratic, and so what should we probably try? We're going to try to factor it. And so it's nice that 2 is a prime number, so we get 2x and x. And so how do I get to 14? 7 and 2. And so one of them is going to be negative because I got a negative going on there. And so now I'd have 2x and then what? Minus 7 and x plus 2. And so now I set both of those equal to 0, and so I end up getting x is equal to 7 halves, and x equals -2. Now I need to check to back substitute it. So when I substitute in 7 halves, will it work okay here? Yeah, 7 minus 3, we're good. Will it work here? Yeah, that's positive. This is also positive. So does 7 halves work? Yes, let's try -2 now. Does it work here? No, we can't take a log of a negative 7. That's not right. And so that's an extraneous solution again. So I'm just left with x equals 7/2. All right. All right, so before we talk about multiplying exponential functions, we need to know our power properties. And so if we remember our power properties, we'd have like 2 to the power of x times, or 2 to the power of y. What did we do there? What did we do to our, when we had a power to a power? You multiplied them. And so this is like the same thing as saying 2 to the power of x times y. Okay, and so that's going to come into play here. So, just like logarithms, if they have common bases, we can kind of get rid of those bases. All right, and so if you look at example A, do they have the same base for this exponential? Yes, so that's cool. And so we can just kind of strip away the bases. So now we're just left with 5x minus 1 is equal to 2x plus 7. All right, I personally like to keep my x's positive, so then I'd have 3x is equal to what? 8. And so x equals 8/3. However, let's look at part B. So one of my bases is 8 and the other base is 2. Well, I want them to have the same base. So what could be the same base? Do I know anything about 8? It's 2 cubed. So 8 is the same thing as 2 cubed. So I'm going to manipulate this a little bit. So I'm going to say this is 2 cubed to the power of 3x minus 2, which is equal to 2 to the power of x plus 5. Now, what are we going to do with this cubed and this 3x minus 2? We're going to multiply them. And so I can get rid of my base 2's basically, but I have to multiply these. And so how many x's will that be? 9x minus 6, which is equal to x plus 5 here. And so now when I start solving for x, how many x's would I have on the left side? 8. So now I have 8x is equal to 11. And so then I get x is equal to 11/8. All right, cool. So let's look at the next one. And so I have 9 as my base and 27 as my base. Well, what could I use as my base? A 3, exactly. So 9 is the same thing as what? 3 squared. And so now I have 3 squared to the power of 2x. And 27 would be what? 3 to the power of 3, and then to the power of x plus 2. And so now I can kind of get rid of my base 3's. And so what do I have on my left side? 4x is equal to 3x plus 6. And so then x equals what? 6. All right, cool. Let's do it again. And so now let's look at part D. So now I have 1/2 as my base, and I have 4 as my base. Well, what could be my common base here? I don't want 1/2. I don't want to think that hard. I'm just going to use 2. I'm just going to use 2. And so how do I use 2 if I have a 1/2? That's really what? This is my childhood. Remember? This goes to the basement. So the 1/2 is really 2 to the power of what? -1. All right, 2 to the power of -1 is 1/2. All right, because where does it go? In the basement. And so it'd be 2 to the power of -1 to the power of 5x plus 7, which would be equal to 2 to the power of 2 to the power of x. All right. And so now I have the same bases, so now I can get rid of those bases. However, what would be my exponent on my left side? -5x and then -7 is equal to 2x. And so now let's get our x's on the right side, I personally would. And so now I'd have -7 is equal to 7x, so x is equal to -1. All right.